So today we are going to cover the final part of GDAL and then starting with the PK tools. But before going down into the deepness of PK tools and finish up the GDAL, I want to spend a bit of time in not for really release, let's say, the output of, sorry, the result of the assignment, but just to give an indication, because I didn't receive many, less than half have been sending the so the assignment. So I would like to have at least for Thursday a good amount. So whatever, usually you need, every time that you have a task in coding, try not to think about the final task that you have. You have to think about the final task, but you don't have to achieve immediately the final task. You have to go step by step to arrive to this final. So in our case, we want to create a text file where you have for each, a text file like this one, for example, where you can, for each date, you have all the observation coming from the different station, okay, for the mean. Be careful, the mean is already given in the table. So if I enter and I get the mean, in other words, the mean is the second column. So don't build up any mean. You just, when I say grab the mean, it means just to collect information under the second column. That is the value of the mean. So as a first, you know, so the final one is to have this text file. Don't think now about the final result. Try to step one step before. So one step before is what? Let's work with one file, and we need to grab information about the name of the station. Okay, name of the station, we know how to grab the name of the grab. Yes, to grab any pattern in the file. No, we have seen quite easy with the function grep. You get a pattern of all the file. That's it. Perfect. So now at this point, you want to, with this command, you get, you know, whatever is here, but you are not interested to have all of this one. You are interested to have only the second column. Actually, the third one, because this is the first, this is the second, and this is the third. So how am I going to use it? I'm going to use awk piping, awk, syntax of awk, and say print $3. Okay. So actually, no, I make one more mistake. So it's not 3, but it's 1, 2, 3, just the 2 dots, and 4. Okay. So pay attention that this one, even if it's more than one space, awk is considering like a space. Okay. So by printing number 4, I'm printing only the ID. Okay. So I have the first column. So now let's see the latitude. Latitude is the same. So this one, you start to copy paste, and you put in a, you know, you put in a text file. Then you do the same for latitude. Okay, let me see latitude. Okay, so you do latitude, I think it is with, okay, so the same is 1, 2, 3, 4 is perfect the same. So you do again, so in the end is perfect the same, print number 4. Okay, so this one, at least this, oh sorry, at least this one, you should be able to do it for one file, okay, by the command that was mentioned to you. That's why also on the chat, on the Slack, I say, do whatever it is you are doing, because it's important to try and try, okay? They say every programmer becoming a data scientist when it's coding faster, you know, so it's a matter of try and find out the different tricks in order to become faster, and then of course you will not try anymore, but you will go directly. Okay, so then when you build up for one file, for one execution, then you do compile the for loop for each single station. And to get the list of the station, we know already, sorry, the list of this one. So we know already that this one, for example, you can say, now we give another look over here, there are all this symbol, and here also this one. So if I say grep whatever is starting with 1, okay, or, and you find a double option that is this one for grep, so you can insert in more than one, but also starting with 2000, because one is for 1000 something and the other one is for 2000. So you can do like this too. So this one is going to give you so is US dollar dot mon. This one is going to give you all the information about this one. Okay, so but now you want what you want. You want only this information and you don't want everything that is over here. So you can do again AWK. Oops. You say print $1. Oops. Print $1. Okay, so print $1 now is giving me to this one. Okay, but I don't want this. So how I can do it? Okay, so if I use the separator and you search for the separator, that is going to be 2 dot. Okay, now I can say print $2. Okay, oops, print $2. I don't get it, that one. Okay, because it's this one. So maybe it's not that one is good. You have, in this case, it's not good to have the separator, the 2 dot separator, because if not, this one become $2. So you search for another stuff. In this case, now we could see the one that I said before, G sub, that is this one, use and insert space, print dollar. Let's see, with print $0 is everything. Okay, syntax error. So in this way, you start to become fast in whatever is needed here. And of course, now I'm not checking the help. If you don't know the syntax, you have to every time check and checking. So as you can see now, there is no separator over, sorry, there is no the 2 dots over here, but so I can start to say, okay, print $2. Okay, so this is all my list of dates. So now actually I can even say, okay, do perfect the same with a comma. Okay, because I don't want the comma too. You put another G sub, but rather than the comma, I put also this one. In this way, I get rid of also the comma. So now it's printing all the dates. So, and we know that if we sort it and if we say unique, piping unique, okay, is becoming, now it will take a while, especially the sorting, I'm going to get, you know, all the unique day. Indeed, you can see, you know, 2014, 10, 11, 12 December, and then the 2015, January, February, and so on and so on. So this is how you get the list that you need. Okay, so try to split in little single part in order to then to achieve your the request that we have. Okay. Okay, and then again, it's a matter of trying as much you can. Some people did very good, some other are very close, but some other I don't know because you didn't send it. So please send it, whatever you have. And again, even if it's applied to other data set, to completely different tasks, is also fine. Eh? Okay. So anyone has some question about this one? Okay, without really the full coding, but if you, I was trying to do this and I could not succeed. But as I mentioned to you, the best way is try and try and try.
Giuseppe, I actually have a question about, I think, the syntax of awk. So how do you know if you're looking at your command right there, you have you're going G sub and then you're just doing a semicolon into your print command? How do you know when to separate that into two? You know, you're using the beginning and then the middle and end curly brackets.
Okay, beginning is everything before to reading the file.
Mm-hmm.
Beginning. So now we are not doing anything. We are doing something in the file. Okay, that over there were three actions. Mm-hmm. Beginning, central, reading the file, during the reading the file, and just in the end. We are not printing any header or doing something before reading the file. And we are not neither in the end of the file. We are just doing during the file reading. So during the file reading, you know, so no beginning over here and no ending over there. So during the reading, I need to get rid of, for example, now this G sub, the comma that was here, but also the two column. So actually, don't you know, I build up. I didn't know that I was going to need G sub, but as soon as I did print $2, I realized actually print 0. This way, I can see everything. I can see that, you know, over here is completely glued together, but this information, actually this one is coming from the grep, because the grep is telling you where from which file is going to use it. Okay, so then you need to take it out and then you search, okay, how to remove a pattern in AWK, and you come across the GSUB. Okay, and then you say, okay, let me remove this one and with the space, because the default is space. And then you find another one, let me remove the comma with the space, and you find the second one. Okay, and then when you have the list, and now, okay, I need to make unique, but the unique works if they are sorted, and then you do sorted and then unique. Okay, so you build up step by step. Okay, so we all also do it. For example, as soon as I do that, I forgot that grep was using this one. Okay, so it's a matter of try and see how to perform it. Okay.
Yes, thank you.
Okay, very good. Any other question in this direction? Okay, so I will give you another two days, yes, until Thursday, and then so before the class Thursday, please send the homework, whatever you have done, and whatever you have done. So
I have a quick question.
Yes, please.
I sent over the Python. I basically just used like awk commands to try to do it, but then I wasn't able, like the last command when I was trying to pull down the actual mean values, it was just pulling down the column header. And so I kind of didn't understand like how that was working, because I guess I could like post the command that I used, but it was basically that like paste -d and then using grep to pull down, you know, the different columns. And yeah, like I said, I mean, basically I just ran it again, and I can pull down the station ID, lat long, but then it just pulls down like quote unquote mean, you know, for the full column header, or for the for that
So the
value.
mean, I mean, the mean, you don't have as a, you don't have to build up the mean. The mean is just this one. Is that just a second column?
Mhm.
So you need to just grab this second column. Why now is getting only this? I think what you say, I don't know. I need to say the line in particular. Okay, but what
Okay.
we want is just, you know, this, the second column, this one.
For sure.
Okay, so try. It's a matter of trying.
Okay.
That is a matter of trying, and
Yep.
okay,
Alrighty.
okay, cool. Then let's move now. Let's move to another exercise that I asked last time. That was not compulsory assignment, but was this one in particular. Okay, I go from here. This one, study case, data type in GeoTIFF. Okay, in particular, I want to bring back anyone try to do this assignment that was also for, it was not compulsory. So, and in particular, it's quite cute because it's also, you also learn it another way of creating text file. So anyone was trying to do it, this one. No? Okay, so the topic was trying to identify and see which was the GDAL command that you need to put over here. Okay, so this one was selected in particular because if you don't do properly, you are you don't do properly, and now we are trying to do it together, you are going to encounter the problem of the GDAL data type that is over here. Okay, so if you remember these issues over here, these issues, this command, this table, you need to always be careful about the data type and how you treat the data correctly. If not, you don't get syntax error. You get a result, but something is happening to the data and you don't realize. So this one is the typical example that you need to select properly the GDAL data type, okay, in order to do it properly. So let's have another table over here. This one, this way I can shift, and we go back to the exercise. So what the exercise is doing is creating, first of all, is creating with thanks to Oak. And now please pay attention because this is a very handy way, handy, let's say also quite efficient for this kind of job, to create a TIFF file starting from creating a matrix, because a TIFF is nothing else than a matrix. So what do you do it? You, and in particular, you using a particular format that if you do in GDAL translate -- format, we are going to use this format. Is one of the first. Yeah, this one. Okay, so what is this one? Anyone coming from the old Archinfo? No, because okay, maybe Giuseppe. Okay, so this one is the so-called Archinfo, ASCII file. Okay, the Archinfo ASCII file was nothing else than a text file with the first, so a text file, an ASCII file text, where the first row giving you the information about the matrix. This one giving to you the information about the lat long position. Okay, so is in the equator 0, 0, if not somewhere else. So in our case, we are just creating a dummy variable, so with the 0, 0. Okay, so and then the cell size that again is going to be dummy for us, so 1 meter, 1 kilometer, whatever you want. So this one was one of the first raster file created from the previous Esri and I keep using because it's the only one that is a text file. And sometimes it's very good because you can manipulate it. You can see the number rather than the pixel. You see the color, okay, or maybe one by one. So by AWK, in this case, we are using why we are using the beginning over here. So JD, this is a question for you.
Because you're asking it to do something after you're reading it. You're asking it to read something and then do another procedure.
Yes, actually, I'm not reading anything. There is no file over here. You see?
Mm-hmm.
There is no file. I'm creating. That's why I'm using beginning, because I'm creating something before I just creating something without reading any file. Okay. So here, the beginning, I create a for loop, okay, with another for loop. Okay, and be careful about here. I have the same dimension of this one are the dimension of my matrix that you can change according to what you need. Okay, and over here I'm printing my number. Boom, 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 boom. Okay, just number that I want to use. Okay, so at this point, so I can really, you can use the Jupyter, but you can also copy paste directly in the terminal. Let me go directly in, for example, now I'm doing this test, so it's very good that I do it CD/TMP. This way, if I create something, then it's going to be removed. Okay, so now I can run this line and I create this dummy ASCII file. Dummy, I mean, a little ASCII file to show. Paste. Yes. Okay. Geodata. Okay. Let me create for security. I create. Actually, this one was inside. Let's go inside this directory. My Ascii data exercise. Over here. I think it's this one is the one. It's the same that should be. Over here, you have my geodata underscore small. Okay, perfect. So now I can paste again. Paste. I lost it. Copy. Okay. Yes. Perfect. So now I have it. So now if I cut it now, I can see that I have my ASCII file with this number. Okay. So now I can convert this one to, with GDAL translate, due to that is an ASCII file supported by GDAL, and we saw how to do it with the GDAL format. I can create a TIFF file. So again, I can paste it over here, paste to clipboard, and I paste it. Okay, now, so what is the task? Okay, let's be, now I want your help. I want to multiply this number by 2022. Okay, whatever is not, it's just a dummy. Here I put a Python. Okay, Python 3 in order to do some math. And I want to be sure that, you know, if I do like this, 222, okay, I get this number and not another number. Okay, and this is the result. Over here is the correct result. Okay, so for example, 622 is this one. If you see the last one, is going to be 66 if you multiply the last one by this one. So now we need to build up over here, and we need to get the right formula. Okay, so first of all, my number are quite big, so I need to select the right data type. So which data type I'm going to select? Question for everybody. This is the number.
Float 32.
Sorry?
Float 32.
Okay, let's try with floating 32. Okay, so perfect. So GDAL calc. Paste the GDAL calc. Don't remember, so I get a help. It's going to be data type. Okay. Alonso say float 32. Okay, and then calc equal, and then I say -a with the name of the file, that is this one. Okay. GDAL, no, sorry. Geodata small raster ID .tif. Okay, float 32 calc. Okay, formula over here. We say A times 2222. Okay, this is what, and then we are going to put also the output file, that is this one. Paste the clip. Okay. Maybe some syntax error. I think the type is here. Okay. Is it correct, this formula? Everybody say yes, also Aphrodite, no? Okay, so syntax is correct, no error. Okay, now let's see, let's build up. Let's see if we make correct. Okay, in order to see if it's correct, let's change back to the Ascii file to read it, to be able to read. Okay, so I'm going to create this, copy. Oops. Paste to clipboard. Yes. Okay, and now I'm going to cut. Okay, so let's see what we have. Okay, first of all, where this number come from? No data value. Why is becoming this number? No data value.
That's what the float 32 assigns it.
Perfect. So these are the extreme of the float 32. Okay, so is the extreme negative number was negative, yeah? Yeah, no, actually positive number. So is this one of the float 32. Okay, perfect. So now let's see if the math is correct. Check it out. Is it correct or not? Not at all. Here there are two errors. Okay, why these errors? Well, actually, look, by this one, what is this? Where this number come from? 29, I mean, yes, why this number? 20,019, look. Anyone? Look here, 28. Okay, so is something in the GDAL calc formula. Okay, how this point is treated? A, this one has to be floating also. Okay, so you need to put the floating point, the floating that also for GDAL calc need to be floating inside the NumPy, because you specify over here as an output, but you didn't specify during the computation of, okay? So this one is the first one. So if you go back to the GDAL calc lecture and you go to calc, so you can see over here GDAL calc, that over here you have as a data type float. So first of all, we need to use this one. Okay, so now you are sure that during the computation of Python, over there is going to be floating also. Okay, so let's run it again, this one. So no syntax error. We do it again, the conversion, and let's see the result now. We do the cat. Okay, so it's getting better, but it's not perfect. Okay, it's getting better, but it's not the one that we want. Why this? Because we need to be careful also about this. Oops, about this one that was, in other words, you are over this range. Okay, JD, you are with numbers that are bigger than this. And then over there is where you have all the not precision, uncertainty in the machine computation. Okay, so you have the result. You don't have syntax error. Okay, but you need to do it properly in order to perform this kind of operation. So how we are going to do it? The final result is this one, float. Over here float, because as someone of you, Python is using as a default double precision, so float 64. But here the output need to be also here 64. So if you do it here as a 64, I don't know why that is not as a 64, now you are going to create the ASCII file and you cat. Now it's going to be correct. Okay, so this is the number that you want. Okay, so that's why this table print it out and put on your desk. Okay, because it's very important every time that you do a data type conversion, you need to read this table and see in which range you can be there, you can use it. Okay, so the number was not was quite big, so we could not use, correct, yes, was too big, so we could not use int 32. So JD say, okay, let's go with this one, we have 38 digit, so no issues about the size. But if you are overpassing this range as an integer, then you are going to get these issues in the rounding of that Longzhu was explained the other day. Okay, so that's why it's really important to also to do this little assignment, because you really understand what is happening inside. Again, you don't get syntax error, okay, but the results are wrong, and you don't realize also because you know you have a huge matrix, and because the number below will be fine, is whatever is happening afterwards. Okay, so this is the practical way of, and I also have it, I always have this kind of little matrix that I have 10 by 10 with different number, that every time that I do something that I want to be extremely precise, I do and I check. If I use a filtering technique, if you use PK tools, and you can creating this one, you know, you can create a dummy one with 0 everywhere. You can create a dummy one with 1 everywhere, or with ID 1, 2, 3, 4, 5, by just changing this one in a proper way. Okay, and then every time you do some tools that you are not sure, you use this little computation. Okay. So surprising, Aphrodite, about this?
Yes, surprising.
Surprising, okay. So be careful about this error, because sometimes I really, nobody explain you, and then you try to do the inverse math and it's not coming, and then maybe you have 2 pixels that are issues in this way, and they're coming across several times. Okay, very good. And always, again, always keep in mind this one. Okay, so let's continue with the GDAL before addressing the other one.
Right, so I'm confused why because I thought all the numbers we're using are integers, so I thought that the float 32 would be big enough, but it's not.
But it's not, because we are overpassing. Yes, good, like JD was, because you are overpassing this. So you are out of this threshold. So when that one is precision, when you are over this one, actually, because they are positive, so over this one, you are going to lose precision. Okay, so the number will be there, will be included in the 38, but is not going to do it. And you know, for Aphrodite, I was never using so huge integer number. I come across when I build up the global basin ID, sub-basin, that we have integer number. So when I do the math, I was not coming out, you know, because they were not unique ID, because some unique, they were not unique. They were more than one. And they say, why? And then I discovered these issues, but took me a while. Okay, so this is where it's important to know, understanding what is behind to see how to do it properly. So every time that you change the data type, and also that you are dealing with the no data, because the no data, again, you cannot put, if you are using these, you cannot put in no data equal minus 9999, because it will not be supported. Okay, so always, so it will be supported. It's good to have 0 or the extreme value, for example. Okay, so pay attention about this. Very
Giuseppe,
good.
does
Yes.
that mean that, for example, if I do a raster that get out of those limits, my my biggest value will be to the 27th, you know, the
Bravo, very
precision?
good point. So if you say, let's suppose that we do it everything with int, let's do a small one, int 16. Perfect, very good point. Even if I leave this one as floating, and I do, so now I translate, and then I cut. So it's going to be, everything is going to be my last number over here, because all my number are bigger than this number. So they will be truncated to the minimum range. Okay, good point, Alonso. And sometimes we just do it and you are truncating. If it's a big, again, if there are many pixels, then you will see some pattern, okay, and you will realize. But if there are few pixels here and there, even if you visualize, you don't see it. Okay, so always think what is happening when you do the data type conversion to your data set. Okay, and how you do it, you do minimum maximum and you check the maximum string. Then you do the mathematical computation, and then you check again minimum maximum, and to see if your data has been rounded or not. Okay, very good, Alonso.
Giuseppe?
Yes, please.
Oh, sorry. So even if we have a small number, can we use the float 64 by default? Will that affect any memory, something like that?
Okay, so again, the float, every time that you increase the data type, your image is becoming, of course, this is just an example, is becoming bigger and bigger. When it's bigger, more time in reading, in writing, and in processing. Okay, so of course, if we are dealing with land cover, I'm not, that usually is 12, 15 numbers. they are going to be always in byte. Okay, so I'm not going to use float 32. But again, if I need their small number, like I was mentioned the other day, like Celsius. So they go from -50 to +50, and you want also the digit after the comma, so 2, 3 digit, then you use a float 32. Okay, but again, we also say, if we multiply everything by 10, the Celsius, it can be stored as here, you know, -500 for the Arctic zone and +500 for the desert. Or you want 2 digits, you multiply by 100, okay? So this is how you try to come across with the best, okay?
Thank you.
Oh,
So in the example we just did, instead of turning it into float 64, could you just divide it by like 1,000 or something to get it below so that it's smaller than the 160?
yes, of course, bravo, yeah, that one was another trick. You subtract everything, because in our case, you know, this one is my smallest number. So if you subtract this one become 0, and this one will become 100, because here I have one increment, you know. I have just one increment. So that one is another way of do it tricks in order to reduce the data type. Okay, good point, bravo, Sebastian. Yeah. So in that case, then you can use the even byte, but the integer 16 or 32. Okay. Yeah. Okay, very good. So let's continue in this line of the GDAL calc that we didn't finish last time. So we open the, so like usual, let me close. Control D doesn't work. Okay, yes. Okay, so like usual, you do you enter in Ascii data, and please do it because we update the stuff, and you do git pull. Okay, you're pulling, then you do the sync, the synchronization with, so R sync, again Control R, and I get a full line, then I copy. Okay, Control R, and then you start to type R sync, and you get the line. Perfect. And now I'm going here to change the directory. So CD over here, and you open the file that we were using the other time. So CD exercise, and then you do GitLab. Actually, you do source, Control R source. You enter in source, and you have the Jupyter notebook. Okay, and you enter in, you do Jupyter lab. You open the the GDAL OSG. Okay, perfect. You arrive to this page over here. Just to be sure that we are using, not copy paste, is easier. Perfect. So we were passing, last time we were passing the GDAL calc. GDAL. Okay, so we were here and we were dealing with this data type conversion with exercise. I think we stop somewhere over here with the use of GDAL warp for changing pixel resolution. GDAL warp is mainly used for change projection. Okay, so when you go from one projection to the other one, in particular, you need to specify, okay, over here, I didn't specify anything because I'm just changing the pixel size, but without specify any change projection. But something to keep in mind is the use of this one. If you just write EPSG, usually it's coming out very fast. So there is not the first one, but this one, a spatial reference list. Okay, so this one is the best data source for all the different projection information. Okay, so always keep in mind this web page. In particular, if you write over here some particular data product like MODIS, you can search all the different projection that has been used for the MODIS. Or even if you write a country, Italy, you can see, okay, all the one that has been used in Italy. And for example, also USA, United States, has the NAD 27, NAD 87. There should be somewhere one of these. Okay, so you can read, yeah, this one, not the 83, and then there should be the 87 or something. So this one is the most common one. So one that we are going to use often is the 4326, APSG 4326. So 43, I think I can even change here, 4326. Okay, so 4326. Yeah, okay, so this one, the 4326, is the most common one for lat long projection. So every time that you use GDAL warp, you need to specify if you want to change the projection from one to another one. So in our case, we are not changing projection, but we are just changing pixel resolution. So, but if not, you can write, you can see to the help of GDAL warp, and you can see that there is the dash A, this is target, source, and target. Okay, so target is the final one. So if you use this one and you do dash T SRS APSG 4326, you are going from one to the other one. 4326. From one to the other one, okay? So, and then you can also specify the source. Okay, but anyway, so in this case, we are working under the same projection, and we are just changing the pixel resolution. And the pixel resolution I'm specified by this one, okay? So again, this one, if you remember last time, is going to be in degree. In particular, remember that 0.008 is 1 kilometer at equator. And where this number comes from is 120, sorry, 1 divided by 120. So with this one, you do all the map. This one is the cropping of the target. T stay for target, try to remember, T stay for target, target extent is this one. Be careful that between GDAL warp, you can also crop and define the extent with GDAL translate, but they are different, okay? One is in this direction, the other one is like this. So every time, I don't know why they make it different. Every time you have to think which one goes which, okay? Because over here is X min, X epsilon max, but GDAL translate is like this. I mean, is this upper left X and then upper low Y. So even after several years, I'm every time checking which one is which, because I always get confused about it. Okay, so with the for loop, I can implementing a for loop and say, looping through all my file, please do a GDAL warp, and I can compress my file. So pay attention about the compression, because always use compression, okay? So these are the most common one. There are different one, but this is the one that I always use, okay? And this line it can be used in all the GDAL and all the PK tools. So just use always this compression, because the file can become even more than 10 times bigger. So it's very convenient to compress, okay? It's not a matter of 1 or 2%. It's really, it's quite a lot, yeah. So from a few hundred mega, it become 2-3 giga, okay? So it's really important to compress. So at this point, yes, Alonso.
Is it compressing the matrix and also the set value?
No. Is a very clean compression. So the data, they don't get lost. It's not a change in pixel resolution. It's just compression without loss any information. So always compress, okay? It's not like when you upload, you send your photo through WhatsApp. Over there is a resampling on the fly, okay, in order to become light, and of course you lose in resolution. But this one, no, it's just a compression without losing anything.
Okay.
Yeah, very good. So over here you can do you can run this line, and you can see that I'm going to loop into all this image, okay, and getting at a small resolution. Okay, so this is quite important because when you are going to working with many files, you are going to loop through many files, you want very speed, and especially GDAL translate, and GDAL warp a bit less, but GDAL translate is extremely fast. You make a really good compression. You can all crop the image and so on. So try to use as much as possible this one. Something also that you need to consider that we didn't see yet, but is also very handy. This one, base name, is the return of, if you have a file, any file that you want, let's see, inside one direction. So for example, this file. Okay, so if you have one file, you say base name of this file is going to return just the name without any directory. And if you take out, in this case, the PNG, the extension, so you write PNG, is going to remove just the, okay, you get just the name of the file. And then it's very nice over here because you declare the variable, and then you declare, okay, you keep the same file name with the file crop. Okay, so this is quite handy because you can adding more information about which kind of file you are going to use. So you will see I'm using quite a lot to get this file name. I remove the extension. Okay, pay attention, you remove the extension. The extension, again, is just an adding to the test. You can remove even more. If you remove 220 here, you get 220, you get just, sample. So you can remove whatever you want, not just extension. Quite often you remove the extension because you're adding some other information, and then, or you can also change the extension. Okay, so again, also in GDAL translate, in GDAL warp, you have the option OF, that stay for output format, that is somewhere here, that again, you can change, you can create a JPEG, a PNG, other raster file, okay? So this is something very handy to use always. Okay, so
I had a question about that command.
Yes, please.
So when going back to the code where you put it back in, where it says file name _ crop TIFF. Why is the file name in brackets?
Okay, because this one, yeah, good point. Because this one, okay, so this command is return me a string. Okay, so in order to do this, I'm going to create a variable and I'm going to give to this variable the output of the previous command. So in other words, this one is giving to me a command, is giving to me a result, and all this result is given to the file, to the variable. Okay, so is embedded as output. This output is going to pass, you know, to this variable that every time is changing in according to this. And quite often I use always the same. I even sometimes copy paste from previous line, you know. I always use, because for file in boom, and then the file name is the typical my variable name without extension and without any directory, and then I adding something else. Okay, so be careful that this is a quite new wave of coding in Bash. There is also the old one that is the with the back single quotation. Actually, I don't use so much. I don't remember neither where it is. Ah, this one. Back single quotation is this one. So it's perfectly the same. Pay attention that you can also find this syntax, okay? But nowadays I always use this one, is a bit more modern. Okay. Very good. And then of course, if I yes, if I print file, now it's going to return to me just sample. Okay, so actually in order to get, should be file name. This way is perfectly the same like the example. If I do echo.file name, is going to print the file name. Something also very a good habit to do it is printing the variable. This way you can see where the for loop is running. So over here I could do echo print $file, and in this way I can see file or file name. I can say echo process $file. This way I can see, if I run it again, I can see somewhere that is printing, probably, yeah, probably is this one, processing. Actually, no, it's this. Because this one is the information from la, and this one is my process. Okay. So it's very good to print the in the for loop for two reasons. First, you can see what is going on, because GDAL translate is printing, so you can see, but sometimes Oak is not printing anything unless it's making a mistake. So in this way, you can see where it's going. And second, also because printing the variable tell you if you are making some mistake or not, you know, it's very common. And sometimes you can, okay, so if I do it here, let's see. If I do it here, what is doing? Anyone? This is very good also to debug in this way. Aphrodite.
If you write echo there,
Yeah.
it's not a variable. So
if I run,
will it print the text? Yes.
Brava is going to print what is going to print whatever I'm going to execute, but without execute. Okay, so this one is very good before to running the execution, especially if it's long. You can see if what you are going to run is correct or not. And then eventually you can even copy paste this line. So over here, it's just printing, it's not processing anything, okay? And then you can create, copy paste this line and paste it in the terminal and see what is going on, okay? So this is a very good for debugging, putting an echo, and rather than processing, printing what you are going to process and then debugging and see. For testing, is very good. Okay. Very good. Okay, so something extremely important also, and this is, for example, in our computation with Aphrodite and Marlene, we are using a lot of the GDAL location info. to get information at one particular location, okay? So if I have a TIFF file, okay, I can run over here, this one. I can get the information of this TIFF file, and in particular this one, in two ways: by giving the X and Y position as a row and column of the matrix without lat long. Okay, if you don't remember, if you don't specify anything, this one is X and Y of the matrix, row and column. And be careful that it's starting from 0, not from 1. So the first pixel is 0, 0. Okay. So if you get 1, let me try over here, GDAL info, and you do geodata. Okay. Let's take it a second. And let's set the, okay. I can get this one. Okay, it's given to me, if I do 0, 0, it's giving to me just the first pixel. Okay, let's get one. Perfect. Okay, so if I get just one, it's going to retrieve the value of the first pixel in the row 0, 0. So remember, it's starting from 0, 0. So if you do it 1 and 1, it's going to be is growing in the X and Y direction. Okay. So indeed, look, here is given to you pixel and L stay for line, pixel and line. Okay, and this is going to be the value of band 1. If you are inserting the information about lat long, geolocation is given to you, and you are using lat long of that file, is giving to you the information at that lat long. Okay. So the val only is going to remove all this information over here. Okay, it's going to remove all this one. So if you run this one, now you are going to see for each TIFF file, how it's performing, how it's running. Pay attention that this one is extremely big, extremely fast. We are really, in our computation, we are putting text file with billion of row and billion of X and Y coordinate, and it's just, I never crash it, okay? So it's really, if you try to do it in R with the function extract, is going to be a nightmare, this operation. So we always create this huge text file in using GDAL location info. And of course, you can play carefully about this one and manipulate accordingly, okay? And you can insert in more TIFF file, you can adding the different column, and by combining with paste and so on. So it's really handy in this context. So, and this is the example. So for example, if I do it, I create a little txt file. So over here, I create a txt file, and now of course, I'm creating just 2 for convenience, but this one can be billion of row, okay? I can pass, be careful about this one, is a bit fancy. I can feeding this one, okay, in the GDAL location info by redirect to GDAL location info. So you invert this direction. And over here, you can print. Over here, I have just 2 rows. So I'm printing over here. Okay. But you can also, using paste and other command, you can also you know, now I'm printing like this, but you can printing also like this, then another 2 here, another 2 here. So you can really play as you want. So try to play, and especially for people doing a species distribution, or even when we are going to see the study case of tree height, we're going to use this GDAL location info to build up the table outside Python or even outside R. Okay, so this is extremely important for the building the machine learning environment. Any one of you was using GDAL location info already, apart Aphrodite, Marlene, Sebastian, Alonso?
Can I mention two things that gave me trouble?
Yes.
First, the file with the coordinates doesn't have to have a header.
Brava, yes, brava, very good. Yes.
Because else it doesn't work.
And I think you don't get any error, or maybe you get error, I don't remember. So no header with the coordinates. So indeed, I didn't put, of course, first the X and then the Y.
And then you have to check that none of the points falls into the sea, because otherwise you get the results for some of them and then you don't get anything. And it's
Yeah,
confusing.
so the no data is empty, if I remember correctly. When Aphrodite is saying in the sea is the labeling as no data is empty, if I remember correctly. So in other words, this one is going to be completely missing. So over here, you are going to be an empty command, an empty line. So it's going to print, but it's going to be empty. Okay, so how you do it? I think, okay, no, wait a second. If you go out, it's going to be empty. If you go out from the teeth, it's going to be empty. So in other words, if you do this one, so I put something that does not exist, and you do the val only, it's going to be empty. Okay, so this is what is happening to you, I think, Aphrodite. You are out of the extent. So if you don't do the val only, it's going to tell you that is out of the file. But look, over here is empty. So if you don't print the val only, it's going to stop over here, so you have an empty line. Okay. Rather, if you are hitting the seed, like the no data, is going to print the no data, if I remember correctly. So try to check. Okay, so now I don't know what is the no data for this, but, and I don't know where is the no data, you know, for me to see. Anyway, you do the GDAL, so the minus 099, then you open. So how you do it? You open. Okay, so the minus 99, I think is over. No, it's not neither here. It should be somewhere. Anyway, you check where is the no data, and over here you get this pixel line, and you fake and you see what is the result. Okay, very good to find out these tricks, because they are losing a lot of time when you don't know. Yeah. Okay. Anyone else that was using this data want to share, or was using extract in R, was taking age?
I don't understand how to see the value with a coordinated latitude and longitude. For example,
This one, just
like,
adding
yeah.
geolog.
Okay. But for example, the coordinates are 33.3
Yeah.
and 2.
And 2, these are the degree of this image, of course. They need to be inside. Okay, yeah. And of course, if you take out these val only, I think it's given to you, is given to you the pixel location. So
Okay.
this is also good to give you information, you know, and actually if you put something out, like let's fake completely something out, like it's going to be something, you run it, it's going to tell you, the position, but it's out of the range. Okay. So this is also
Okay.
good to see a lat long where is located inside to the matrix. Okay, it's very handy, this one.
So this is more like an area, because the pixel is a specific point, right? But this one is returning a lot of pixels.
Yeah, because I am looping, yes, I'm looping through different teeth.
Okay, yeah.
Okay, I have 12 teeth, so it's going to return to me 12 value.
Position.
Okay.
Okay. Okay.
So if I run like this, it's going to return 12 value. If you have only one teeth, it's going to return only one. Okay, and this is how you looping, not through only one point, but through many. Okay, many in this case only two, but it can be longer. Okay.
But everyone that you're looping through has the same extent, right?
Yes, yes. Okay, if it's not the same extent, some they can be empty. Pay attention. If some, you know, it can be completely empty, because for that one is going to be out of the extent. Okay, so especially for using all these tools, GDAL, MPK tools, that's why it's very important, going back to the previous, to have all the pixel resolution in the same, the extent perfect the same, because sometimes you don't get a warning, but you get something weird, you know, you don't know how the software is going to deal. So it's very good to spend a bit of time with the GDAL info and with the GDAL edit to have everything in the same coordinates and under the same extent at digit level. Okay, very good.
Giuseppe, can I ask a question?
Yes, go ahead, Haman.
For example, you have 12 values here. How should I know which values belong to which diff?
Okay, so question for everybody. You want to know this one from which diff which team belongs. So there is an easy solution and a more, yeah, let's do the easy solution. Anyone? Chomi, you are talking, but you are in, I mean, you are not in mute, but I cannot listen. You can do with the letters. Anyone here? What I have to write, easy?
Can you just write echo file?
But yeah, echo file is going to give me just the information about the file, okay, for each one. And then if you want more fancy and you want to have over here, how you're going to do it? You can do it like this. And you can put in brackets this one, okay? But this one is going to be a bit weird, because it's giving to you, no, look, it's giving to you, look, I was not expecting this. It's giving to you for each file, but rather than like this, in this direction. Look, I didn't know. Okay. So it's giving to you in this direction over here. So in this way, you can build up the table. And of course, if you put over here your file name, is going to save it in a file. Okay, everything that is printed is saved to a file. Okay, very good. So there is a way there is another way we saw before, how to transform the text file, TIFF in text file, that is using the format X and Y and Z. Okay, so pay attention. This is not is how to manipulate a TIFF file in with OGR. but is not an efficient way from a processing point of view. It's really for some cases. Don't start to convert all your TIFF file in TXT file, also because it's going to be extremely huge and you cannot working. It's going to fill it up your RAM immediately, your hard disk immediately. So in this way, what you are going to do, we are going to run it. Okay, if I run it and I see this file now, so the file that I'm creating now, copy. Why am I not pasting? Anyway, and the file that I'm creating now is going to be 3 column vegetation. Okay, it's going to be 3 column where for each pixel is converted in X, Y, and the value of the pixel. Okay, now it's just a text file. So again, you can open as you want. Be careful that now this one is huge in terms of, you know, because you have your matrix X and Y dimension becoming as a table, and more you have information about X and Y coordinates. But this is the way how to change a TXT file, sorry, a TIFF to TXT file. At this point, what we can do it, we can use Oak in particular. We can manipulate the third column, this one, the third column, and changing the pixel value, the value of the pixel. So now if you run this one, and we are going to see the same file, you can see that the TRH, the one with threshold, okay, you do cat dot TIFF, no, TXT. So has somewhere okay, somewhere as becoming 50. Okay, now I can bring him back to TIFF, and my value now, if I bring it back to TIFF, okay, I already run it. Now, if I open this one with the OpenEV, I have my pixel value that where the AWK if condition was applied was becoming 50. So it's somewhere, this one you can see this gray area. This is how you change the pixel size. Again, is not an efficient way. We will see a better one with the PK tools, but something can be done with this one. And it's useful because sometimes you need to understand what you are doing. So this is a good way to do it. Okay. Okay, perfect. So let's finish up with this one with the build VRT. And this is extremely important because the build VRT allow you to, so for example, in this case, we are going to merge four different TIFF, okay? This merge is virtual. That's why it's called build VRT, stay for virtual raster type format, okay? And in particular, it's just a text file that is creating links, okay, to the TIFF. So try to use the build VRT a lot, and you can use a VRT to do two kind of mosaicing. You can do a vertical mosaicing with the option separate in this case. So all the different layers become band. So you can see over here. So these two layers have become inside to the VRT. And I'm going to check with the GDAL info, these two, and you can see that over here it has two bands. Okay, so now I'm just merging the two bands like this. I'm not merging, I just overlay. Okay, so over here, let's suppose that this is the image. I want to split in four, like this, in 4 quadrants. So what I can see, I can use GDAL translate to split in 4 quadrants, upper left, row right, and so on. And I can use the one that we said before, source wind, with the dimension of the TIFF. And then to re-aggregate back, I can use the build VRT. So in other words, now, before I was doing like this, separate, and now I have the 4, 2 here and 2 here, and then I can re-aggregate back to the TIFF. Okay, so this one is how you do the splitting procedure using the VRT computation. And you can run it and see one by one how they have been splitted. Okay, so if you go over here, this one I can close it. And you go inside to the geodata vegetation. Inside the geodata vegetation, you can see how they've been built. So these are the one, if I run it now, oh, sorry, I forgot to run this one. You run this, and then you run this one. Now you can see that my upper left TIFF has been generated. I can even open. I can open it with the OpenEV, and you can see over here that there are 4 different 4 quadrants that you can switch and eliminate. Okay, so if you have this mosaic, then you can rebuild the full TIFF by using these other 2 lines. Okay, so you rebuild the you build VRT without the separate option. So again, the separate option make like this, and no separate, you make like this. And you can use the GDAL translate to reassemble it back the operation. Of course, these are just simple, but then if you have many TIFF file, you put in a for loop, you can create and assemble it whatever you want. Okay, so this is very fancy. Okay, let's have a break, also because if not, it's getting longer, and then we continue with the OGR. Okay, so we come back at 50. Come back to 50. Okay. Okay, so now let's continue a bit with the GDAL, and we move inside to the use of GDAL for working with the GDAL elevation, the digital elevation model. So in particular, not before, for creating buffer. So with the image, GDAL proximity is the one, and again the .pi is because it's been written in Python. So you can also open the Python code over there, and you can see how the Python code has been running. Okay, so if you open this one, the proximity, you can see, and you have to specify from where. So if you open this one, it was a center point over here, and then it's creating like a buffer proximity. So it's nothing else that you can specify as a pixel, distance unit as a pixel, or you can also specify as a kilometer. Okay, so you need to read carefully the manual when is better one or the other one. And in the same way, you can also do a fixed proximity with a proximity buffer. This is a continuous surface. Rather, if you open the other one now, so crop buffer, you can see that has been creating a buffer. So again, be careful. Sometimes the stretching is not the right one. So you just press it. This one is going to show you better color. Okay, so you can see that now that was buffering from here. So it's 0, and then over here is 4, and then more over here is 10. All these value you can specify over here you know, maximum buffer distance equal to 4, outside put 10. So it's quite fast. We have been using quite a lot for our computation. So there is, even if it's a Python code, because the Python are slight slower than the C one, is going to be succeed in any case. So with this one, you can do all the distance element inside to the raster file. Then there are all the different one about the one that you can use it for dealing with the digital elevation model. You can calculate the slope, calculate the aspect, calculate the some topography index. And in particular, so now if you go inside to the directory and you open the geodata dem, you open the slope, is the one that is creating the slope from the dem, okay? So pay attention from the slope, okay? Don't rely on the slope on GDAL. Be careful, because there is this, and pay attention for everyone, there is this value that need to be changed. This is valid, actually is even one of in my error in the beginning. This value over here is correct at the equator. So if you are in lat long and you want to calculate GDAL, you have to change this value in according to your latitudinal position. So you have to make a bit of math. And you say here is working 90 degrees, and then up to the north, the center of the image is going to change up to arrive to 0. Okay, so what does it mean? That if you do, this value is going to be valuable for the center of the image, and then up and down is going to be slightly wrong, the slope. So if you have a global area, don't do with the GDAL, the slope is going to be not correct. So be careful that this is something that, especially if it's lat long, in lat long format, everybody's making this big mistake. Is not really well written over there in the manual, so it's not very well now known. And if you have to do a big massive computation of slope, do it with grass, okay? Because the GDAL in slope is wrong. Okay, so in fact, in my paper, in the geomorphometric paper, I have done everything in grass the slope, because GDAL, again, if the tile is very big, is going to be just correct in the center of the image. So pay attention about this, and the same for the aspect, because I mean, no, the aspect is not affected so much by the changing of projection and so on. These one are different kind of topographic and roughness index. So you can easily TRI. So this one, they come quite correct. So you can see that they give you roughness of the terrain. So you can play and check all the but these are the most common one that they do it for the terrain. Then again, there are different commands. If you do GDAL and you press it, you press it tab twice, you get all the list. There are some are very new, like GDAL, PanSharp, and so on. So again, pay attention, try to discover by yourself. I during the lecture, probably say maybe 20% I mentioned, and there are other, most of the option I could not explain one by one. So you can do quite a lot with GDAL. In these regards, there is also the brother, let's say the correspective for GDAL is the OGR command, that you can do a lot of operation with vector file. With OGR, there are mainly, even if they come up more than, but these are the most important one, OGR info and OGR to OGR. With the OGR info, you can get information about the info for vector file, okay? And you can see, for example, over here, you can run and you can see that it is pretty similar to what you get with the GDAL info. So you get about dimension extent of the shapefile, projection information, and then you get also the attribute table over here. Pay attention that over here I have inserted geom no, because if you don't do it, it's going to give you the information about each single lat long of your polygon. So they can be extremely long. So always use the geom equal to no to avoid this long border. And this is the attribute table that you can get. Of course, whenever you print it, it's going to be in a text file in the terminal, so you can manipulate with the AWK. So let's make an example. For example, if I want to, you know, I want all the information that I don't know what it is, but about FIPS. I say grep FIPS. Okay, and then I run it. It's going to print all the attribute of the table with the FIPS information. And again, this is again a text file. I can manipulate with awk. So I can say, okay, print me only this information about, probably that this one are the country name or something. So 1, 2, 3, and 4, I can say AWK print $4. Okay, so now we can run it again. It's going to print only that one. And I can even say, okay, sort, the typical sort unique, tell me how many, and maybe I can put C. I can see how many country there are in the world, and maybe I can even put 1 in case someone is repeated. You know, some country are not continuous, they have something else far away like Hawaii and United States, so I don't know how it's been treated. So I put the counted in the country name. Okay, so I have this one that is null, so I can check why is null. That one maybe is the Antarctic, so there is no country over there. So this is how you use OGR info to get information from the attribute table, and you can play as you want. So this is the beauty of OGR info. Pay attention that inside the info you can have also SQL. What it is? Yes, this one, dialect, SQL dialect. So over here in SQL command you can do query. Okay, so this is the case of, for example, this one where I do it, you know, an SQL. Okay, still an SQL, but with the function where. So let me open this shapefile. In this way you can understand what I'm doing. SHP, so is TM, no, TM border. Word border SHP. So this one I can also open in OpenEV. Okay, so you don't have so much, you cannot really click and get the attribute, so it's a bit, but for this fast visualization is good. So this is the typical, and you have the attribute for each single polygon. Okay, so so you can do, for example, the selecting only the polygon where your country is equal to Uganda. So now if you open, rather than world, you open Uganda, you're going to get, probably didn't run. Okay, it's opening automatically. So you are going to get only the Uganda. Okay, so this is how you can do the selection, and you can do the OGR. OGR to OGR is very handy. You can do a lot. So over here, if you press it OGR to OGR, you can see, and actually there's been adding quite a lot in the last 2-3 years. In the beginning they were very small. So you can do it, of course, a spatial cropping. You can do also cropping, even if I didn't use so much, but you can do cropping with another data source. Usually I always prefer to have control with the coordinates. You can do overlay between the different polygon. And of course, also here you can do, you know, clipping procedure and so on in the manual. Now, if you go to OGR manual, there are quite a lot of examples. So it's quite straight to do it, okay? So you can also do it something more fancy. For example, you can calculate, you know, you can calculate the area of a polygon and then select only the one bigger than 100, okay? Again, so this is the case where bigger than 100. So pay attention that every time that you are working lat long, then you have to check what this 100 means. It's going to be 100 degree, could be, and not in meters. So the 100 degree over here is different than here. So always pay attention, and can you retrieve information about kilometer square rather than degree in OGR? This one I don't know. You need to check and see if it's possible. Okay, so this is quite handy for this aspect. So with this last point, I've been closing the GDAL chapter. Anyway, we will keep it open in the sense because we are going to use it quite a lot during the information, and especially, you know, especially for your final work, is good that you start to preparing with GDAL, cutting to the same extent, you know, pixel resolution, be sure organizing everything. Because if you are working with one file, nothing happened. But if you are working with, start to have 2-3 different files that you, and usually who is going in the modeling, we have the different predictors that can come from environmental data, from climate data, soil, digital elevation model, and so on. So you need to standardize this digital elevation. So a good source can be, a good example can be to start to dealing with the information that I collect in the syllabus for the compulsory assignment. So start to using Wget for downloading the data. So never try, always every time that you go in an internet site, try to, you do right click in the file that you want to download, and then you do right copy link address. Now I don't have, but even if you go here, you know, this is a link of the file that you want to download it, you do copy link, and then you paste this link into your scripting procedure, and then you put Wget in front. Okay, so start to having this, because it's very important which is the source and which is the file that you have been downloading. Okay, well, tomorrow you are losing the file, you want to check if they make another version, you have to have this link, because if not, you don't remember. It's quite often they also, the name of the file is not very explicit in terms of versioning and so on, so it's not very efficient. And with the GDAL, try also, yeah, to make these, cropping, merging, change projection, using VRT also to see and so on. Then we are going to see also PK tools, but let's see, maybe we see next time. Okay, so some of you already started to use GDAL for the final study case. You want sharing some information about it? Anyone want to say something?
I had a question about VRT.
Yeah.
And when would you want to, merge the tiles, make a mosaic, and when would you want to just have them separate, but so you could see them, like, is it?
Okay, perfect. Let's see, yes, good point. There is an underline. So you have to think that one can really open the door of the massive processing. Okay, so in other words, when I was creating the VRT, yeah, so over here, why I'm doing this? This is a dummy example. I split it and then I reaggregate it, but for doing what? Okay, so I completely skipped something in the middle that is in according to whatever you want to do it. Let's suppose that these two data sets, you know, are too big to process. Okay, so what you do it, you, okay, in this case, you want to create 2 band, then you split in 4. Okay, at this point, you have 4 different files, each one of these having 2 data sets. Over here, you do some other operation that can be one, but can be cropping, reclassify, merging, whatever you want to do it, you know, several processing with this one, and then with this, and then with this one, and so on. And then you reaggregate back. Okay, so the VRT is useful for this, for splitting the file. Okay, do something with the file independently, and then reaggregate back. Okay, so this is going inside to the multi-core processing that actually, due to that, you are bringing up. Let's do it now, this example. But before, anyone has some other question in this line that I was struggling with GDAL to do, or can GDAL do this? I was searching, but I could not find.
I have a
Anyone?
question about
Yes.
the variables that you put. For example, in the line 27, you got like RN-F. For example, the DAF F, where can I find what does it stands for? Like,
Okay, so for example, this one is a bash command that is for remove. So you do man rm, and you get, you know, you get
okay.
all the optional. In this case, the F stay for forcing. F is quite often is F forcing to do the operation, forcing the operation. Okay, to do something. So in the same context, if you do man GDAL translate, okay, you get the long, you don't get only this, but you get keep pressing, and you get all the different information. Rather, if you do just GDAL and you enter, you get the short L. So you don't get any information. But if you want, you do like this. Usually I use for GDAL translate, maybe I do a bit more the web. I go on the manual but you can do it the same over here, especially if you know, because here you can search, you know, by pressing the \, then you can search, for example, resampling, and you get enter, and you get select a resampling algorithm. Okay.
Okay.
So this is how you can do it. Anyone else will say, I was struggling to do this with GDAL, I could not succeed.
Giuseppe, I'm just wondering, when you're looking at the SQL commands using OGR to OGR, is there a way, how would you, suppose you're not looking at a global map, you're looking at polygons and you're not sure what they're called? How can you tell? You know, is there a way to look at the names of the polygons in a vector file?
Okay, of a specific, okay, you can, like I did before. I mean, I would try to open, I would try to open in QGIS and get at least some information.
Okay, that's what I've done in the past. I was just wondering if there's something you could do on the command line.
If you really want to, I mean, you can get at least all of them. Okay. But if you want to get, let's suppose that you want to really get one from United States. Yeah, let's suppose you really want to get the one from United States and you don't know that is United States. You don't know that it is United States. So you can get this information over here. You can guess it, you know. Okay, the ISO is going, ISO 3 is going to give me the country name. Let's suppose that this file is so heavy that you cannot open. So because there are also this case, you know, okay, first of all, if it's too big, don't work with a vector file, because this is a mistake that everybody does it. As soon as it's becoming more than 1 giga, 2 giga, the way to go is raster environment. If not, you will spend a lot of time in processing that will take age to finish, okay? So if you really cannot open, so what you do, you crop it to a small one by using cancel this card. So yes, by using OGR to OGR with the function, with these two functions, you know, with clip destination and this one is spatial. And then when you have small it, then it's going to be smaller. You open, you try to understand what is going on, and you say, okay, this is the item that I want, and then you do OGR info to get this information from the file. Whenever it's too big, try to crop one single part and then opening. I also sometimes get a file that is too big, even due to that I'm remote, I'm not close to Yale now. I crop it and then I download it only a small file of 200 mega. Then I can open. Okay, seems okay. I can see it, and then another part. So you can always use these tricks in cropping and downloading and open whatever you can crop.
Okay, thank you.
Point. Okay, somebody else was trying to do something fancy with GDAL. Okay, so let's see, due to that, was asking from Sebastian how to do, what the VRT can do it and why we are going to use it. Let's see this one that is really fancy. Is the multi-core processing, the PK tools we do next time. So yeah, it's under bash. So if you just click under bash multi-core processing. Okay, so over here, you have to do a little trick in order to do it. You can decide to do it or you can just follow. It's the same procedure, it's not going to change a bit. So we are going to use it, a multi-core operation under bash using GDAL function, okay? So in this context, if you do, if you press it over here, yes, the command top, actually htop, is giving to you how much processor are going to use it, okay? So most of you, unless you change something, you are going to have only one processor. Why? Because if you go into the virtual machine, 1 second, but you cannot do it now, you need to shut it down, but maybe you can just listen. If you do setting and then you do system, over here, you can increase the number of processors, okay? So if you're shutting down everything, you can, rather if the virtual machine is on, you can change, okay? So I put my to 2. Be careful, if you already have the green area that is over here, don't put 2, just follow up with 1. It's going to be the same, but you will not see the multi-core processing kick in. And then when you start it, it's going to be 2 processor. Okay, so let's see what is happening over here. So let's open this data set. So we keep that one open and we open with the Jupyter, so source. And we open bash xarg, so Jupyter Lab, bash xarg OSGeo. So these one are perfect the same than the files that are there. So if you open this one now, it's going to bring to you perfect to the same web page, and let's see what is happening to the processor and how to work in the multi-core of and actually this can be even something more advanced. The same exercise for the people that handling, for example, the exercise with the GSIM, the for loop that you have done, you can change in multi-core for loop. So it's very fancy and quite straight to do it. So let's see how we operate. Okay, let's suppose that we have several TIFF, okay, and we want to change the pixel resolution. Actually, yes, we want to change the pixel resolution. Oops, change the pixel resolution, and during the changing, we want to make an aggregation. We want to calculate the average. So you have several pixels, and you want to aggregate to this resolution. Actually, yes, to this resolution and making larger resolution, getting the average. This is something that can be done now. So over here, pay attention, this one is just to calculate the time that for the processing. So for file in this one that are 10 file, actually 9 until from 1 to 9, to echo the file in order to see what is going on and running the GDAL translate. So as you can see now, look, is working. Yes, one by one, but only one processor is working. So over here in the top, you can see sometime when it's finished, you have the shifting, okay, of the processor like now, but most of the time is only one that is working. So in other words, you have a Ferrari, but you are going in a very slow speed, okay, because you are using just one part of the force of the computation. So most of the time, every time that you use your computer, 90% of the time, you are using only one process, okay? And even GDAL translate, GDAL warp, and so on. So this is where you can try to have always this H-top very handy, and you can see what is going on, okay? Actually, even better, you can do another one. So pay attention to this one. Let me put over here. There is another one that say PS out, yes, okay. So this one is the same, is giving to you what the computer is doing and with what I'm doing quite a lot. Okay, so over here, so for example, now I should get, okay, it's over, but I can rerun and I can see that GDAL translate is going to come over here somewhere. Actually, you know, top. Yeah, actually, yeah, over here, terminal, yeah, GDAL translate, this one. So with the H-top and with the top, you can see the command, the GDAL translate that is running. So as you can see now, it's running only one time. This is the giga that is using, okay, the megabyte or gigabyte that is using, and this is for the percentage of memory. So also this one, so now is over and the GDAL translate is completely gone. Okay, so so you can see that the time of processing is 42 seconds, more or less. So now let's pay attention how we do it, the for loop. How we change the for loop in Xarg, in the multi-core using Xarg. Okay, first of all, the command is this one, is called X and arg stay for argument, and the S for the stay for the plural. Okay, this is a command that Aphrodite doesn't like it. Every time he's struggling, she told me. So now maybe she can get some hints about it. So in particular, what I'm going to do it. First of all, I'm going to list the variable that I'm going to perform. So if I do list. I can list. Okay, Control L. Okay. I can see that over here I have n variable. I pasted something else. LST months and then .diff. Okay, so I have 10 file that I'm listing. With this ls, I'm nothing else than listing this 10 file. Okay, then I do the piping. Okay, I do pipe, I run xarg, I pass n stay for argument. What does it mean? I pass one argument, so this file to one processor, this one to another processor, and so on. And the P stay for how many processors I'm going to use it for the xarg. Okay, so this one say that I'm going to use bash, and this one is the opening of the for loop, of the xarg loop, let's call it. Then it's going to be perfect the same. File, I call it file equal to $1, where $1 is my argument, is the one that is changes, the one that comes from here, and $1 because it's changing is first time this, second time this, and so on. And I call it equal to file 2, equal to file. Then this one is perfect the same, nothing changed. Okay, so it's like the one before, you can compare. Then this one is the closing of the loop. Pay attention, space over here and nothing actually, yeah, okay, if there is something doesn't, is not, but space over here. So this one is closing the xarg, and again, this one is opening the xarg. So now let's see and let's run it. So if you run it now, you can see immediately that the two processes are pumping up. So now you can see the two are running at full speed. When one is over, the other kick in. And you can also see that the two processes are running because you see over here the information of the GDAL are in overlapping. So the 10-10, 20-20, 30-30, because it's depending who is printing. So they are printing together, okay? And then, of course, it's going to be much faster. And how faster? Twice the speed of before. So again, this is how you change the for loop in an XR for loop. It's pretty the same. You have to just change the beginning and the end. So I always suggest, and quite often I do it, I build up just a normal for loop, and then you just change this one, okay? So this is the way you compare, and you can see the result now is 28. Okay, so going to the question of Sebastian, this is how the VRT were useful. You split it in 4. Okay, so you split it in 4 over here at this time, at this point. Now you have 4 files that you can go in multi-core. Okay, now of course I build up with 4. You can build up with when we run stuff in the cluster, there are different node build up, so the tiling system is continuous. That's why the splitting and the reaggregation, they need to really precise in pixel resolution. So always a digit, because then when you are reassemble it, you are going to have pixel overlapping. You don't know which one is coming first, and so on and so on. And of course, if you do some operation that need the nearby pixel, like filtering, for example, so you do larger TIFF, you do the filtering, and then you recrop to the right position. So you do 10 pixel more, and then you take it out the 10 pixel in order to do the right tiling, okay? So it's really depending what you have to do, how to calibrate the tiling. And you do everything with GDAL translate, build up VRT, and GDAL translate to reassemble it back, and so on. So it's a combination of these operations. And how you, when you have the tiling system, you just put in Xarg. More or less, just to give a, when the image is, let's say between over 1 giga of TIFF, you start to do the tiling system, okay? Below one giga, you can just run in GDAL as it is. But if it's more than 1 giga, tiling system. For example, now in our work, we have been creating a TIFF file of 80 giga just because the user requested. But I will never work with a file of more than 1-2 giga. I will split in tiles, because if not, it's becoming too. For doing a test, you have to always wait, okay? Rather, if you split in tile, you can keep working with one tile to do operation, and then you say, okay, done. Let me build up the Xarg, and you run it in parallel, okay? This is how we combine it. And you will see over here, you can insert, if GDAL doesn't do something, you can insert PK tools, okay? So this is how you become efficient in this context. And you know, a normal desktop has easily 12 CPU, and you can go without problem. Actually, if you see, let's run it again. Maybe we run it, the GDAL with the command, the other one, GDAL max something. There is a variable that is called GDAL max. I think it's something like this. Equal, and then you get, you don't remember if there is an underscore or something, and you give the maximum amount of RAM that one processor is going to use it. Okay, so this one is going to use, sorry, in mega. So it's going to use 2 gigabyte each processor. So if you have, you know, you have 12, you can use, and you have 50 mega, no problem. You are going to use without problem. So this is from one GDAL translate. So if you are using, you know, 8, they are going to be in total 16. So if your computer is 20, no problem. Okay. So with this one, you can really play in a beautiful way. So so this is the example. And the beauty of Xarg that you can pass even more than an argument. Okay.
Giuseppe,
yes.
I have a question. Can you repeat, please, the meaning of the meaning of the options of Xarg?
Okay, perfect. So yes, I was here. So again, with the ls, I'm going to list a file, and I have this, just a list of file. Perfect. Then I have the piping and Xarg. So I'm going to say, I'm going to use Xarg. N is the number of argument. So in this case, the argument is 1. So means that it's just a file. We will see below 2 arguments, just one file. Okay. And P is the number of processors that I'm going to use it together. Okay. I mean, together, one for one file and another one for the other file, not together for the same file. Okay. So then this one is that I'm going to use bash inside my Xarg, and this one is the opening of the Xarg loop. Let's call it in this way. Then this one is just for convention to say my variable is going to be file equal to $1. And my $1, this is the argument that is passing from here. Okay, so it's going to be this one the first time, second time, this one, and so on and so on. So if you see from here below is perfect the same than up. So this one is perfect the same. Doesn't change.
But what else can be instead of bash? What else can we use instead of bash?
Inside here, okay, now you are making, okay, let's use bash. Then we go the soft. Yeah, can be done, can be done. But Here I use GDAL translate, but can be anything that Bash support. So I can use awk. Be careful about awk. Here you can spend age, because in Xarg, whenever you use this one, you have to do the escape. Pay attention and please put a note. Aphrodite is laughing because she spent a lot of time in discovering this. Okay, so you have to always single quote. You have to put escape. Okay, so but you can use it. So here you can put whatever you want. Okay, you can put sad. You can do cat, whatever. Okay, now the question: can I put another? Yes, yes, you can. You can put a Python code over here. Okay, so if you do Python 3 and you have your Python that does, I don't know, table cleaning .py is going to run twice. Okay, okay. So because this one is going to be a bash, this one is going to be a bash command that is running a Python command. Okay, so over here you can even do $file. You can put the argument that are passing inside Python, and in Python you have, how you call it, the system.args that you can insert the I think the system.args that you can insert the argument inside Python and start to read. So this one is going to read inside here. And this is going to do the multi-core with Python, calling from Brush. Then there are going to be other way that you are inside Python and you do the multi-core. But this is how you use Bash for the multi-core operation. Okay, so the flexibility is enormous. Okay. Something to consider is also, please pay attention. I didn't say all this stuff to make the, I mean, if you have a variable outside Xarg, let's suppose that you have this one out dir is going to be my variable. Okay. And what you want to use dir, you know, for the file name. So over here, ls, correct, yes, $dir. You want to use here. Right, and you want to use here, $dir. So in other words, I'm going to use one variable that I declare outside to the for loop, to the Xarg. So for this, be careful what you need over here. You need to export a variable, the bash variable. In other words, the variable, like when we say the bash variable, every time that you change an environment, that can be Python, that can be R, that can be Xarg, you need to export it to let them available to get from another software. And this is going to, you do the export. If not, Xarg will not use it. So pay attention about this, to put a note. Okay, so if you want to use variable, bash variable inside Xarg, you have to export first. Also, this one doesn't give you any error, just don't use the variable. Okay. Okay, cool. See, yeah, so let's spend these few minutes for a few other questions. Anyone else is starting to say okay? Longzhu.
Yes, can you hear me, Giuseppe?
Yeah.
Perfect. I just have a thought. You talk about buffer from GDAL when you talk about approximate function. I was wondering, would that be equivalent to change the pixel resolution of your map? Because initially, let's say you have a coastline that's in the resolution, whatever you define in your original map, and that's one line. Now with the buffer function, you kind of broaden it. Would that means the pixel resolution for the coastline region at least is being expanded? Of course, the other areas will be contracted.
No, when it was not really a buffer, it was just a cropping. So rather than cropping from 0 to 1, or from, let's say, from 1 to 2, then you cropping a bit more, 2.2 and 0.8, you do the filtering, and then you crop it back to from 1 to 2. It's not a buffering that you buffer it around, you expand it, or you change the pixel resolution around. It's just a cropping of your tiles that is going to be large. Okay.
But on the map, you show it actually the borders look like blurry. I think that's kind of saying something the pixel resolution. I mean, intuitively.
Yeah, there can be some cases. There can be some cases that you can change it and having pixel resolution. But in other words, everything can be customized according to what you want to do it. So you can do it, you know, you can even working with pixels that are not square, but it's very rare. So everything can be customized and according to what you do it, but it's important that you have this flexibility with GDAL, and we can see also with PK tools. Okay, we can go back for this specific use.
Okay, I was just wondering. Yeah. Thank you.
Welcome. Okay, so let's jump into the final information, not more lecture. So we go to going back to the syllabus. I was just to mention that you are going to have two assignment for next. Both of them are not, I mean, there's a sense of compulsory, but we need to decide if we are going to if you are coming to Matera. If you are coming, you are going to make a deposit of 100 euro using the same procedure of the registration. This deposit is going to give back to you if you are coming to Matera. This is also to help you, everybody, to know how many people are coming, okay? So in this regard, we are quite good in terms of people. So because they has been updated, so we are more than 54%. So I expected to have more than 13 people. So everybody reply, and maybe some people that say maybe we can even shift. So again, and I'm going to write again also into the Slack before the class, make the payment of 100 euro, and as soon you do it on Thursday, I'm going to do the green light. In this way, you can book accommodation, book fly, and so on. Over here, if you go back into the geocomputation announcement, there is the direction and accommodation, where you can find all the information about how to arrive to Matera. You have to fly to Bari, and it's very beautiful. You can spend a few days also if you come with your family or some friends, and the coastline is very nice, and we can organize also some activity. It's going to be a hackathon, a sort of hackathon. So from 9 o'clock to 5, where you're working with your code. We will do some slide presentation, probably with some. Maybe I will try to also invite some guests as soon as I know how many people we are. But it's going to be so. I suggest to you, don't come without anything, because we are there to solving problems. So if you have more problem that you figure out, then you come there and we try to solve it. But if you start from there, also because consider that we are 26 people to present, because also the people in remote will present. So if you put 20 minutes each, so 2 days and maybe even 3, they are going to be just for listen presentation. So you are going to have like 2 days, 2 days and a half to really work on your data. So come with already something very, very final, okay? So yeah, so this is the web page where you can find all the information about how to count train line and so on. So yes, I will post this information, and if you have question about material or some other, we will be happy to reply.